Good evening, ladies and gentlemen. Welcome to today's session, which is on developing a sampling plan for quantitative and qualitative research. My name is Princess Masondo. I am from the College of Graduate Studies. I'm based in the School of Interdisciplinary Research and Graduate Studies, and I'm working there as the college statistician. I just want to make a note that for today, the focus will be on developing a sampling plan for quantitative research. So I'm just going to switch over to the presentation and start with the presentation. So as I've already said, I am Princess Masondo, and the focus for today will be on quantitative research. In terms of what we will cover, we will look at our layer foundation, just introduce some concepts, and we will look at a sample selection and population. We'll look at different sampling techniques. If there is time, we'll look at sampling errors, and then we will summarize. If there is time as well, can look at specific questions that are specific to your own studies. I can take a few cases from your studies. So we are here because you have some questions that you want to answer and which have led you to undertake research. So there are some goals there, and those goals inform the data that you need to collect for you to be able to answer the research questions. So you want to measure a behavior, there's something that you want to know, or something that you want to demonstrate. Perhaps you want to classify certain units in terms of certain attributes. So there are questions that we want to answer, which then says that we need to collect some data so that we can be able to answer those questions. So when we look at the research question, it gives us an idea of the various components and the variables that, so when you look at the questions or the goals, you'll be able to have an idea of the variables that will be collected. And you can, even by looking at the question, maybe also have ideas of perhaps the approach that is likely to be followed. So the questions that you have that you want to answer, they are about people in most cases. In other cases, they're about animals. Sometimes it's other things like businesses, like countries. So there could be a lot of things that you want to, a lot of things that your questions are centered around, such that you have to collect information about those things. So you want to, the questions that you have, you need to, they can be answered by you collecting data from the things or people or animals, as I've said. And the people, the things, the animals, we refer to them as units. And the information that we collect, generally in the context of quantity, as I've said, I'm gonna focus on quantitative. We refer to them as a variable, and it's something that is measurable. So it's a measurable characteristic. So there are characteristics that are inherent in the units, and you want to measure those characteristics. And the characteristics, they are likely to vary from one unit to the other. if you are interested in measuring my hair color or hair color of your units, when you measure one unit, you'll observe a certain color. When you measure the next unit, you might observe a different color. So that's where that it will vary from one unit to another. And then we have attributes, which they make up, these are the features that make up our variables. So our variables are made up of features. For example, if we think about a variable like race, it will have attributes such as Indian, white, colored, and so on. So because we want to collect data from units, and that data is in essence the attributes of those units. So in that collection, we say we are actually measuring the variables, right? And we will assign values or symbols. In the assignment, the values, the units will be measured, and from measuring the units, you get a value. If you are looking at an attribute like GDP, you will perhaps you will get it from documents, and you will have that value that you will assign to that particular country. And the same can be said for the other units. Yeah, so it's more about measurement. So the data that we are collecting, we are actually measuring characteristics of our units of interest. And obviously the units will depend on the attributes that you are interested in, as you can see there in the example below. Then it says that we have to, obviously, we're doing research for us to respond to those research questions, and you will follow the process. Where we are now, the assumption is that you've actually your problem statement or your research questions, they are now clear, they've been stated, and you've also looked at how you are going to measure the variables. So you have the variables that you want to measure, but you've gone a step further to say, in my study, this is how I'm going to measure the variables. I believe there was a workshop on operationalizing the variables. So for each variable that you want to measure, you'll specify to say that I want to measure level of education. My level of education, I'll measure it as a category. It's gonna have these levels, right? Or I want to measure age. So maybe you'll say, for the purpose of my study, I want to measure age as a number. That's for the purpose of your study. And there are many other things that are other examples. When sometimes you have constructs, then you'll have to look at previous research to say, if I have a construct like work engagement, then you have to look at how other people have measured it, and then settle for what you are how you are going to measure it for your study. So obviously you always start with what has been done, and that will assist you to settle at a measurement that, or a definition that will be suitable for your study. And maybe just a last example will be, if, for example, you want to measure stress in your study. There are so many ways you can measure stress, right? Then you'll have to decide, am I going to measure stress? Am I going to ask the people to self-report, meaning they tell me if they are stressed? So maybe I will give them 4 options. They can tell me, maybe in the last month, if they've experienced any level of stress. So the response options can be none at all. Others will say low level of stress, others medium, and then some can say high. So you can see that it's a subjective measurement. But then if that's the way you want to go, you'll motivate why you are going. It's gonna have its limitations, right? Because you are not actually measuring stress, but it's if they think they have stress, you can use tools that are used to diagnose stress, or you can measure certain um, biological responses and certain maybe hormonal concentrations. So you can see that the different, if you say you're going to be looking at hormonal concentrations, it means those people you must have a tool to actually measure. Maybe you have to take blood, and then from the blood be able to determine the level of the different hormones. So there are different ways, but at this point, we are at methods, right? The assumption is all the other things have been settled. You've resolved that this is the design that you're going to be using, whether it's experimental, and now you are just looking at the methods. So in terms of the methods, one of the things will be for you to look at now you are going to collect data. How are you going to select the units? Because we said that the data is in the units. So how are you going to select the units from which you have to collect the data? So this is where we are. We are at the methods, the how you are going to select the unit. So sample selection, it is a process of selecting a subset of the population for investigation. So you select a sample because the population is often large, such that it's not feasible for you to collect data from the entire population, and also because statistically we can also be able to say this is the sample size that you require, such that it is sufficient for you to be able to do your statistical analysis. So sample selection, which is where we are, it is that process where we are selecting a subset of the population, and from those population units, we want to collect data, a certain attributes, characteristics, so that we can respond. So the main thing is for us to be able to respond to the research questions. Everything that we are doing so that we can be able to respond to the research questions. As I've said, at this point, the research question is clear and the specific questions are very clear. We need to find the units now that we must study for us to be able to respond to the research questions. So some definitions, you have a population which is a set of possible units of interest, right? So there is a population of interest where these attributes are there. They are in this population, in these units. The attributes are in this unit. It can be, for example, you are looking at children under 5. That's where the attribute of interest is. And then the size will just be the count, the total of those units. Then we have the target population. So the target population is more specific to what you really want to zoom into. So it will be guided by a criteria. So the population can be general, to say children under 5, but the target population is specific, and it will be guided by the criteria that you as a researcher you will outline. I will show some examples, and obviously the total will just be the count. So I spoke about the criteria. This is what will assist you to clearly define the target population. So this will be specific characteristics or conditions that will make a unit to qualify to be included in the study. And the criteria has to be very explicit, and sometimes definitions are used to actually assist with the criteria, which then assists us to arrive at the correct target population. So definitions, I think I'll show examples, and the exclusion also, which is also intended to assist you to get to the right target population. It talks about what needs, what characteristics or conditions disqualify a unit from being included. And then based on the applying the inclusion criteria, the exclusion criteria, you end up with a sampling frame, which is a list of the units from which you can select a sample. So they will be based on the criteria that you set. So I spoke about definitions. So if, for example, you when you look at your study broadly, you say you want to look at young people, something about young people, but let's say your population, whatever you want to investigate has to do with young people, then you'll have to say there are different definitions, right? So which definition are you going to align with? This is also influenced by accessibility. So if, for example, you want to use secondary data, meaning data that has already been collected for other things, and if, for example, you are in the South African context, you might have to align yourself with the South African definition because of access. So you're gonna maybe use a previous studies in which are using maybe the definition of young people being 15 to 35 years, or maybe you want to use the UN definition, right? So that will assist you to say it therefore means that the people who can be included in my study must be in that bracket. Sometimes maybe let's say, yes, you are looking at young people, but perhaps in your study, you want to compare. You want to make this comparison specifically. So you want to compare this group and this group. So then it means you have to amend your definition of young people in this case so that it can include those who are, because you see these two definitions don't include this. So if you want to make this comparison, you might end up having to say, I'm gonna have to amend it and say I'm including from 13 to 19 years because maybe I want to make this comparison. I want to compare the teenagers and the young adults. And the other variables as well can assist you to include or exclude. Maybe you might want to exclude units with certain health issues or psychological issues. Obviously, your exclusion and inclusion, they have to be fair. They can't be biased, and they can stigmatize people. So another example, suppose we want to measure the impact of exercise on cardiovascular health in university students. So let's say you're looking at university students in the city of Tshwane. So that's your interest. The population of interest will be university students, right? At a high level, regardless of their age, type of university. But now when you zoom in, you now maybe are going to say, I want students who are based at public contact university, so I don't want distance, and maybe they must be below 36 years, right? Meaning they are not above 36, 35 and below, and they must be in the city of Tshwane. Your inclusion will be maybe, as you strengthen it, maybe you'll say they must be full-time, right? You don't want part-time students, you want full-time. They are at contact public, and then they're you between 17. So you maybe you don't want to seek parental consent, so you are excluding those who are below 18. But because you want to do, and you also maybe want to limit the study, even though you are saying university students, maybe you want to limit it to young people. So you will say, you'll specify the criteria, and then the exclusion obviously will just tell us who is excluded. If you are below 18, if you are not full-time, if you are at a distance institution, if it's a private institution, and so on. So this will assist you. After this, for this study, you will now know that you can have a sampling frame which you can obtain, right? Here I said in South Africa, but if you are containing it to the city of Tshwane, then you can access the list of the students. Sometimes they will give you the full list, right? Hopefully, when they give you the full list from the attributes, you can be able to select, to clean it up for you to get to the sampling frame, meaning you remove those who are below 18, you remove those who are part-time, you remove those who are above 35, and then that will take you to your sampling frame. In other cases, when you give a spec, they will give you the data based on the spec that you give. One thing that maybe I want to also point out, a population, we need to also be aware that how the population influences your sampling. So it can be homogeneous, it can be heterogeneous. And when a population is homogeneous, it means that the elements, the units, they have similar attributes. Yeah, it means the units have similar attributes. If we look at the example of when you look at impact of exercise, and if we just focus it on the city of Tshwane, we exclude the University of South Africa because it's not a contact, it's a distance. So maybe we'll be thinking about University of Pretoria, we'll be thinking about Tshwane University of Technology, and there's also Sefako Makgatho. Yeah, I think those are the three that will meet at least. So when you look at them in relation to what we want to study, we're looking at exercise. Obviously, when you look at the topic, you can think about some of the things that will be of interest. Maybe one of the things which will be of interest will be access, right, to exercise facilities. So that can make the population not to be the same, because maybe access within the different institutions that I've mentioned might not be the same. So it can be one variable that it might actually play a role for you to say, these universities, maybe they're not going to be, I must treat them as different, because for the students who are maybe on campus, maybe I might even have to layer it further and maybe exclude students who are not residing on campus, all those things. But just bringing it back to access can make the students to differ, such that maybe the students at Tshwane University of Technology, in terms of the facilities that are available, they will be different to the facilities, and the exercise support programs that are available might differ, which might influence your variable of interest, which is the actual exercise that they undertake, because maybe you're going to be looking at frequency, how often they exercise, what kind of exercise. So access can become, so they might differ. So in that case, they will be heterogeneous, and then it's going to influence your sampling. You will see as we proceed. I'll make reference to the example as we proceed. So in terms of a sample, we are interested in a population. So I've explained that you will clean up you get to your target population. And your target population, from the criteria, you end up having a list, right? But you must always remember that your interest is in a population, and you select a sample so that you can be able to get to the population. You are sampling because it's not possible for you to observe the entire population. But remember, your interest is the population. The sample is what you're going to observe, and what you are observing, in most cases, you want to paste it on the population, or you want to generalize or make inferences. So here's the population, you select a subset, and then you want to, from what you observe here, you want to paste it back because you are interested in the population. You are not interested in the sample. Your interest is in the population. So in this case, the population is the population of university students in the city of Tshwane who are full-time, and obviously the other criteria I've mentioned. Once you've selected a sample, the sample is not the population, but what you will observe from the sample, it's going to paint a picture about the population. You want to generalize. So the sample size will be the total number of units that you will sample. So a sample is a subset. As you can see, you have the total, then you select the subset, and then sampling is that process where we are selecting, and there are techniques that we can use to select. How do we know? How do we select? And the other question is how many units do I need to select? So in your sampling plan, you need to address those two. You need to first describe your population. As you saw that with my example, I started with a high level, and then I cleaned it up as I went along, such that I used some criterias to say this is what I want to focus on. And yeah, you could have said maybe you also want to include people who didn't stay on campus, but maybe you are including them, maybe you want to make comparisons. So it doesn't necessarily mean you have to exclude them. You can include them maybe because you want to compare those who stay on campus versus those who don't stay on campus. So everything is guided by what you actually want to measure. And if you don't, in some cases, the population is very small, such that really the sample is not, it's not necessary. So you will just do a census study. So we want to examine subsets. They have to be representative. So our sampling, it has to be such that it is representative of the population. Since we want to paste what we see from the population, we want to paste it on what we see from the sample, we want to paste it on the population. And obviously we are in the operational costs, that's why we are sampling. And sometimes there are analytical and computing requirements that are leading you. Maybe the data that you have to work with, maybe your study, there are a lot of variables that you have to work with, and maybe your computer might not be able to handle that, such that you have to sample. And sometimes for ethical reasons, you don't want to collect more sample than you need. That would not be ethical, because in other studies, the risks are high. The participants are exposed to risks, so it wouldn't be ethical to unnecessarily expose your participants to risk. So you just want to ensure that you collect what you need. Yeah, so we want to make inferences based on what we collect from the sample. The more representative the population, the more the sample is representative of the population, the better the accuracy of our inferences. One other thing is, I think I'm concluding here, sometimes you get the right size. So as I said, there are two issues here. We have the how many units and the how. In this today's session, more focus is on the how, how you get to your participants or the units that you need to select. But there is the other issue of how many, and sometimes you might have the right strategy, but have a small sample. So it's important to ensure that those two issues are taken care of. Yeah, if it's not representative, then obviously you might have bias, right? And it means maybe you followed your procedure, maybe they are flawed, and sometimes the bias can come because of maybe the people who are not responding have similar attributes. So you are doing a study, maybe it's purposive. Sometimes even when it's not purposive, if we think about the census, I think it's still in the news even now that it was done during COVID, and it was not easy. Certain areas under normal conditions are difficult to access, your high walled areas, but it was compounded by the COVID. So there were areas which were not, they struggled to access, and you find that maybe those areas have similar attributes. So it means that the people that you miss, they have similar attributes. It's not random, but you are missing a certain group of people, then it makes everything to be, it's introducing bias, right? Yes. So in terms of, I'm moving now to selecting a sample. So the different techniques that we can apply to select a sample, they will be influenced by the purpose, right? The nature of the research. I mean, some of the things in terms of your design will also influence the sampling technique that you can use. For example, if you are going to do an experimental study already, it's driving you to a certain angle. And what the other thing that can influence the approach that you take can be the practical issues, right? And theoretical, and the strengths and weaknesses of the different sampling approaches. I will mention them as we proceed. But broadly, there are two approaches that we can take when we are selecting a sample. So I will always make reference to the example of the study of the impact of exercise when we go through this. So there are two approaches you can follow. It's one is you're gonna go probability sampling, or you go non-probability sampling. With a probability sampling, most of the approaches, they require a sampling frame, which is a list of all the population units that meet the inclusion criteria. So if we go back to our example, if we want to do a probability sampling for our university student study, it means we must get a list from the universities. So they must give us a list of the students who meet the criteria, and with some attributes that maybe you will also specify, which will assist you with your sampling. So you need a list for you to be able to do probability sampling. So you must know, one of the things, you must know that you will be able to get access to a list. And one of the features of probability sampling is that the probability of being selected. So you have a list, and then we're going to sample using one of the probability sampling approaches. But one of the features is that if you go the probability sampling, the probability of selecting a unit is known. Some texts, they say that is equal. It's not always equal, but it is known. It will depend on the sampling approach. with other approaches, the probability of selection, meaning that if you are all the students from University of Pretoria, Sefako Makato, and TUT, they will have an equal chance. That's if you use a certain approaches. With other approaches, they don't have an equal chance of being selected. On the other hand, we have non-probability sampling. It doesn't require a sampling frame, and the probability of selection is not known, meaning we can't quantify it. With the probability sampling, you can say that the probability of selecting a unit is this much, and it's gonna be non-zero, right? Yeah, the probability of selecting something. So if you think about a probability, maybe you can think about, let's say, an event. If we toss a die, if we toss a die, it can either land on 1, 2, 3, 4, 5, 6. So if I toss it, it will land on one of those. So probability that it will land on 1 is the same as the probability that it will land on 2, because I'm assuming that the die is fair, it's balanced. So each of those numbers, they will have an equal chance of occurring, whether it lands on a 6 or on a, so you can think of it that way. So if, for example, you will see if you're doing simple random sampling, your units, they have the same the probability of them being sampled is equal. On the other hand, as I've said, you don't need a frame, but the probability of selection is not known because you don't have a frame. This one, you can calculate it because you have something to work with. Here, you have something to work with, sometimes even if it's not a frame, but you have some list that you can use. You have some information that you can use to calculate the probability of selection. This side, when you're doing non-probability sampling, you don't have a list, so you can't calculate the probability of selection. So with probability sampling, one of the features, there has to be some form of randomization. The probabilities, they are assigned to each unit objectively. On the other side, there is no randomization. The selection is based on the subjective judgment of the investigator. And we also say it's a non-random sampling. So I'm moving now to the different sampling schemes. So if we take our example, and I'm gonna use the simple approaches using that example. So with simple random sampling, as I've said, each element has an equal chance of being selected. So it's a known. It is suitable for homogeneous. So I've mentioned homogeneous. If you're gonna take the students from the universities and you're going to see, you're gonna do simple random sampling, you are actually assuming that with regards to the variables of interest, they are the same. So there is nothing that will make them differ. But in this example, I've already said that one of the things that can make them differ can be access to exercise facilities. So in that case, if you think about that, it might not be homogeneous. And as such, when it's homogeneous, it means that I take all of them, I make them one group. Because they are homogeneous, it doesn't matter whether 20 comes from UP, 30 comes from TUT, it doesn't matter. Because they are homogeneous, I just need to get the right sample size. It doesn't matter. So I can put all of them in as one group and just select. If I need to select 300, I can put all of them, the whole list that I will get, and from the whole list, just select 300. So we've already covered the target population, right? So for example, in the example that we are using, when they give you a sampling frame, which should be the list of the students, you need to make sure that there are no duplicates, right? There are no students who are appearing more than once using whatever identifier that they would have given you. You must make sure that you'll also have to specify the year, right? Maybe it's those who are currently registered in the academic year that you are doing the study. Maybe that will be your criteria. So you have to check for that to say if maybe they also gave you the year of registration, or if there is a way. Some universities, the student number, they also use the year. So you can use those things to clean up, to ensure that you have the right people. You don't have people who were registered the previous year but are not registered currently, and you don't have students who are supposed to be there but are not there. Yeah, so with the probability sampling, the challenge becomes the logistics, right? In this case, you are just requesting from institutions. It's gonna now depend on your access and whether it's gonna be feasible for you. You need to actually check because it can make or break your study. I've had people who have decided to do the probability sampling, but now they are struggling to get the list, because it's easy sometimes for for institutions to give you permission, but when they have to give you the actual things, sometimes it's a struggle. Yeah, so with the sometimes you have to revise your definitions, right? When you look at, if they are sending you a list, when you look at it, once you have access to it, you might have to revise some of your definitions. Yeah, and then you need the sample size, which will not cover to say how do you get to the sample size, but we're focusing more on how do you select. So this is just an example. So if this were my students, they are all from they are from TUT, UP, and Sefako Makato. I just put them all together and I select. Because of the time, I'm not able to show you how you to implement this in Excel, but you can actually implement this in Excel where you use random numbers. And yeah, I've outlined the process, but I'm not able to actually open the Excel and show you. If maybe at the end there is time, I can open the Excel and show you. So it's easy to implement. As you can see, we didn't use any information about the students, right? We just put them together because we are assuming they're the same. And then we just sample from the whole group. So you don't need a lot of information about the population. And most softwares, the statistical procedures, they assume that your sampling was a simple random sampling. So the analysis, they come standard with most statistical softwares. Whereas as you start to use more advanced techniques, some of the procedures might not come standard. Suitable, obviously, for homogeneous. If your population is not homogeneous, then there might be bias. So I think I won't do this example because I've already given the example, or this one was looking at smoking, right? So if you are looking at smoking among teenagers, if you have a population of 300, you can use if you are going to do simple random sampling, all you need now is to know how many you must select from 300. And if you assume that you have to select 169, it means from this 300, you don't take into account anything about them. You just select 169. It doesn't matter if all of them are maybe early teenagers, if some of them, it doesn't matter the distribution. You don't care if there is a good mixture of maybe gender, if there's a good mixture, as I've said, of the age differences. You are assuming they are homogeneous, they are the same. So it doesn't matter as long as I have enough numbers. And then I'm moving to systematic random sampling. So with systematic random sampling, you can also hear there is random, right? And with this one, sometimes there are misconceptions because sometimes you can do a systematic sample, but it's not random. Systematic random sampling, what makes it random is that your start is a random start. So you don't just decide, I'm gonna start, let's say you have to take 100 out of 300 and you just decide I'm gonna start at number 50. No, that's not random. That's what you thought. But you can generate a random start, which is something that you didn't specify, but it was generated. It's a number that will be generated. With a systematic, sampling frame is not always required, but you need knowledge about the population for planning. So if you think about, if you're gonna collect data from households, if you work with urban areas, the layout, the houses, they will have house numbers. So you know that if there are 60 houses here, they start here, this is how they proceed. So you know that there's a sequence you can follow. So you can start somewhere based on the random. So you don't really have the list, but your knowledge, you know that you know there are 60 households in that area, and then you know that you need so much, and then you know you can start here, and then as you will see with this one, sometimes you have to do a sampling frame. Sometimes you use the knowledge that you have, like the example that I'm giving you. So you calculate an interval because we say it's systematic. It means you'll be skipping. You have to skip. So how you get the interval, you take your population size and you divide it by the sample size. So if your population size is 300, sample size is 169, that will give you the K. And then obviously you have to round it. Sometimes you have to round it and it can just add 1 or 2, the rounding. So this is just an illustration. So you select a random start, right? The random start will be between 1 and the last. So in this case, the example, if we have 300, your random start will be a number between 1 and 300. And you've already obtained the skip. So if you start here and your skip is 3 in this example, it means you'll be taking every third student. So if we go back to our student example, maybe we have, I'll stick with this, maybe we have 300 students, obviously it's a small number, and you need to take 169. So you'll say 300 divided by 169, which will give you the skip, and then you will have a random start, and then you will be skipping. So sometimes maybe you'll start, the random start will be at number 200. So you can see that it's at the bottom. If you list your units, and then you might have to look up to the top for you to be able to get enough as you skip. I hope I'll be able to show you in Excel. So the advantages also, it's easy to implement. The higher spread of sample units. So your sample units will be spread out, right? You don't need a lot of knowledge because you are not using any other variables. I mean, any other auxiliary information about the units. You are just following a systematic approach. It can be more prone to bias if maybe you find that what you skip or maybe coincidentally it's aligned to certain attributes. So which means maybe you will only select based on those attributes. And a precision law, you've got low precision compared to other schemes if the population is not homogeneous. I think I've explained what is an homogeneous population. So it's less efficient if your population is not homogeneous, because we are assuming that all those households, they are the same if I go back to the households. But if they are not the same, I might find that I'm landing maybe on households that are better off with regards to whatever I'm measuring. Then it will be less efficient. Also, it can be more costly because the units are spread out. Also, they are just spread out across the entire area. Then the other one is a stratified random sampling. Here, you will stratify if you believe that your population is not homogeneous. So if I go back to my example about the university students, I explained that the access to exercise facilities will introduce differences such that maybe some universities have better facilities, maybe which says maybe the students maybe have more access, and maybe some universities, even if maybe they're not better, some universities maybe they have what in terms of when you look at the ratio, yes, of the number of students versus the facilities, you might find that some universities we maybe they have good, but when you look at the ratio with the number of their students, you find that it means that the students are sharing the limited, very good but limited. So maybe then obviously it influences access, which might then influence their behavior in terms of how often they go to exercise, how often they participate in this exercise activities. So this would be a reason for you maybe to stratify. So one of the stratification variables can be, as I say, you will maybe look at the institutions, you will look at them separately, and they will each be they will be their own groups, right? And because you want to ensure that there is the different universities are represented, and perhaps you are also stratifying. It could also be because you want to compare, right? Because you know that there are access differences. So maybe you want to compare what is the impact of this, the differences. So it could be because you can stratify because you want to compare. Sometimes we stratify because we know that from the groups, there are some of the groups, maybe they are small. Yes, so I didn't check the figures for the 3 institutions, but let's assume that maybe Sefako Makato had, maybe let's assume it was a new university, and it didn't have as many students as the other universities. It means that if you don't stratify, it's given that from Sefako Makato, we might not have enough students, but because we want to make sure that they are all represented, we might have to oversample from Sefako Makato. because it's very small, even if you say, I'm gonna sample based on the size, which means the big universities will get the bigger chunk of the sample. So you get your sample based on this, the size. Remember with stratification, if I say I have the 3 universities, it means that if my sample size is 169, I have to share it, distribute it to these 3 universities, right? And when I distribute, there are different ways you can take in distributing. The one that is common is when you say, I distribute proportional to your size. So which means if you are big, you're gonna get the biggest share of this sample. If you're small, you're gonna get so. But with that, sometimes you find that certain groups are very, very small, such that if you sample based on that, from those very small groups, you just get a small sample. So sometimes then you stratify because you want to oversample to ensure that even from those small groups you get enough sample. Yeah, the assumption obviously is that within the strata, within UP, there is homogeneity. The students are homogeneous within TUT, but when you move from TUT to, then obviously they are not homogeneous. That's why we are stratifying. And also, I mean, for the groups, if let's say you want to compare, and there are some, if you want to do a comparative analysis, you'll need to have enough sample for certain statistical analysis procedure. So that's why sometimes you need to know, you also need to tie in, your sampling must be tied in with your objectives. And obviously the objectives are linked to statistical analysis procedures. Yeah, I think I've explained that with this one, because you've got groups, sometimes they can apply different sampling approaches within each strata. Within the strata, the probability of selection will be the same within, but because of, if let's say we take in proportional to size, already the university that is big has the students from that university, they have a high chance of being selected compared to the students from the smaller universities. If we are using the proportional to size allocation. I wanted to, yeah, so these are some of the attributes. I think I've specified them. So you have a population like this, you divide it, you can see you have the blue, the green, and then you select within the groups that you would have created. You don't only use one variable. Sometimes you have to use other variables to stratify, not just one variable. So your groups are created. If, for example, maybe I use the example of when we look at smoking, teenage smoking, maybe I might want to stratify by gender because I know it can influence the smoking prevalence. And maybe I also want to stratify, as I said, it's teenagers. Maybe I want the young teenagers versus the much older. I want to stratify by that. So then there will be 2 variables that I'm using to stratify. So yeah, this is, so the thing that I want to touch on is the allocation, right? So you first have your sample size. I'm using 169. Then you need to share it. In our example, we have three groups that we've created, right? So each one must have a sample size. So it will, if you're using proportional to size, which is common, It's when we say if you are big, you get the biggest share. If you are small, so you get based on your size. That's proportional to size. Sometimes we do disproportionate allocation, right? Meaning that, yes, so I'll use the example of when they sample for maybe a national study, like in South Africa. A province like the Northern Cape is a small province in terms of the number of persons who live there. So what tends to happen is they will have to they can't do proportional to size, because you end up having very few people being sampled from the province, but then you end up having to oversample from that province. That's when you do, it's no longer proportional to size, but it's disproportionate, where you want to oversample maybe small strata. And also sometimes, for example, when I select the sample, I'll start with proportional, and then you find that when you look at some groups, you've got very few people, or if you are sampling schools, very few schools. So maybe sometimes you come up with the criteria to say the minimum pair must be 5. So it means that I'm now mixing. I started with a proportional, but I see that it's not working for these small groups. So maybe I start coming up with a minimum to say, if I'm maybe selecting students from schools, I will say maybe a minimum from a school must be 20. So that will be one of the things I apply. So I might have to take from some of the stratums. I might have to take from there to make this one big or increase my sample. But most of the time you will take from the big ones and put it on the small ones so that they have a minimum, especially when you, in your analysis, maybe you want to compare. And remember, even the ones that you sample, you're not sure if they're gonna respond. You might still have others not responding. So setting that minimum will help you to ensure that from each group you have a minimum. Yeah, sometimes you do equal allocation, right? Which means that if it's the universities, they will 169, they will all get the same amount. So I will just say 169 divided by 3, they will get the same amount. So you can use if, for example, you believe that they are, if, for example, the groups are small, then you can do an equal allocation. And if maybe sometimes they are small and you want to do a comparison at strata level, you can also use this equal allocations. If they are also, their size is, it's not different, it's not that different from each other, you can do equal allocation. There's also yeah, I think I've explained that for comparison. Also, if the cost will be similar for all strata, yeah, so this is equal. You take the big N, you divide by 3. That gives you. Then there's optimum allocation. This one you use it when you also have information about the costs. Sometimes this is a study that has been done before, so you take the lessons from that study. So there is also information about the costs to say this is how much it costed, so you can use the optimum allocation. Stratified random sampling, I think I've shown this. The advantages, I think I've covered this. Cluster sampling, it's another approach where you divide the population into clusters. Usually, it's used with geographical, when you're using a geographical setting, and you can divide, for example, your households or into groups, which you will call clusters. With this, each cluster, it's different to stratified sampling in the sense that with this, each cluster, a cluster must be representative of the entire area, meaning that within a cluster, you must have the different units. So if, let's say, the area consists of people who are poor, middle class, upper middle class, the cluster must have that. So the cluster has to reflect the population, because with this one, once you've selected a cluster, you're only gonna collect data from the cluster. So the clustering, you'll have to take into account how many units you need to sample, right? Sometimes you take one cluster, sometimes you take more than one cluster, depending on the units that you need to sample. Yeah, so you sample the clusters instead of sampling the units. One example is the one example I always give. It's the one when you have in South Africa, you have this informal settlements whereby there are no proper roads, and the structures, the houses are not properly numbered, and you find that the houses are similar. They use the same material, so it's difficult to distinguish them. So when you are working, if you're gonna sample from the whole area, I think maybe I must yes like this. If you're gonna sample from the whole area, in terms of the quality, you being able to actually say with confidence that the house that I've sampled is the right one with a big area, the quality it's reduced. But if you say these areas, I can cluster. So if you look at the middle one, maybe I will use the road. There is a road. So you use the features on the ground to create your clusters, but you create them in line with how many units you need to sample. So here, you might, with this one, maybe you'll end up with about 20. If I just do a rough, if you look here and I use this, you might end up with about 20. So sometimes you might slightly oversample. So if you are looking for 10 households, with this one, you might end up maybe with around 20. If you select this cluster, then it means you come here, you collect data from all these houses, right? And yeah, you use the roads. Sometimes there are shops here. There are also schools. Other features is what you use to describe the cluster, to say this cluster starts here, and then you follow a dirt road. And then when you at the corner, there is a shop, a tuck shop. Then, so you have to describe, because there are no, you don't have the street names. So you have to use the features on the ground. And sometimes the features on the ground, they change, but you try to use the things that you think will be more permanent. I mean, the other example of cluster sampling can be when you are selecting schools, right? If you are doing a study and you're collecting data from learners, then you might select certain schools and only collect data from those schools. As I've said, the assumption is that the school, when you are clustering, the assumption is that when you have selected a school, it represents the population. So it has to be truly in that way that what you find in this school is what you will find in the other school in terms of these variables of interest. So then there is multi-stage sampling, where you are sampling at different phases. So you might have to select schools as one phase, and then the next phase is you select the learners. So that will be a two-stage First stage, you are selecting schools. Second stage, you are selecting the learners. That will be, and you can have more than 2 stage, you can have 3 stage, and so on. So some of the things that you need to consider is access, right? The access to the you can have problems due to geographical, the areas, maybe sometimes they are not accessible. So we're using or logistical or other practical constraints. So here the example here would be if you want to study homeless people, you might have to focus on those who are in shelters. So initially, so here I'm talking about when sometimes you have to revise your initial definitions and your targets because of certain constraints. So here, maybe you want homeless people, but now because you don't know how you're going to, when you've collected data from this one, how you're going to know that you've collected from this one, you haven't collected from the next one. Then you maybe to structure your study and make sure that there is more control. You might have to focus on homeless people, even though your study wasn't. Yeah, so those are the practicalities. Other cases could be you are doing the study during the rainy season and there are areas you can't access. So you might have now to revise what you had initially said, and you need to think about how does it affect now your inferences, how you're going to be able to generalize. The one thing can also be time. So these things, you must think about them when you plan. Some of them, obviously, you revise as you go along, but some of the things you must think about them when you plan for when you're doing your sampling plan. If you think of an example of when you want to study informal businesses, sometimes the informal businesses, some areas you find that maybe there are associations, and you find that because of those associations, there are lists, right, of informal businesses. But in other cases, you find that you don't have a list, which means that for you to access these informal businesses, you must walk. You walk street by street, and when you get to the street, you see, okay, here there's a salon, you go in there. You walk, here there's a tuck shop, you go in there. Here you pass at the corner, there's they are selling food and whatnot. They meet your inclusion criteria. So you don't have a list of these people. It means that obviously you can make an assessment as you plan for your study. And I think those are the things that are important when you plan for your study. When you don't have a list, you need to have an idea of how your population is laid out. Because, for example, I once had someone who was doing a study on informal businesses in the city of Tshwane. If you think about the city of Tshwane, you have the CBD, you have the different areas, like you have the north, the south, the west, you have the locations. So how feasible is it that you'll be able to go to these locations and be able to so in that case, it would have helped them to maybe focus on an area, because even if you just select one area and you say Soshanguve or you say Mamelodi, it is still a big area on its own. To say you're going to do informal businesses in the city of Tshwane, when you don't have a list, you have to be, the way you are going to identify them is by walking around. It's not going to be feasible for you to cover. Then if you say city of Tshwane, your coverage is just going to be very poor. So you need to think about these practicalities when you decide on the approach. And data availability, this one applicable when you are using secondary data, right? Sometimes you might define your population a certain way. When you actually see the data, you find that it doesn't maybe have everything that you wanted. Let's say, for example, there are quality issues with the secondary data, maybe let's say due to COVID or due to some interruptions, you have years where they were not updating the database as regularly as they did. So there is issues of quality for that period. So you might have to now change your study to say, I'm going to look at these years because maybe these are the years where this secondary data is more reliable. Yeah, so you'll maybe focus on certain periods. So these are things that you need to consider. It's always advisable with secondary data to know about it so that it doesn't surprise you when you've already prepared your proposal and you've planned this way, and when you get the access. Remember, when for you to get the secondary data, you must first get ethical clearance, right? And for it means you must prepare your proposal and then apply. So in the proposal, there are things that you've specified, and you are specifying things that because maybe you don't really have access to this, you have an idea, but it's not something that you've been exposed to. So sometimes you specify things that are not feasible. When they give you ethical clearance, when you get the data, you find that what I said and what is in the data, they don't talk to each other. So maybe you have to revise. So with secondary data, always advisable before you do your proposal, try to, even if you don't get the data, but maybe they can send you the variables that are on the data, the metadata, to explain what is on the data. If they say they are collecting employment, what is the definition, and all those things, so that you are aware when you write out your proposal and you say, this is what I'm going to do, it's in line with how the data is. Ethical, legal considerations, I think I used if let's say you are doing a study on what is referred to TVETs, and you want to do a study on maybe students there, maybe because you don't want to seek consent. We know that with the TVET colleges, you might have younger students, more of younger students compared to your traditional, normal universities. Then you might say you want to exclude students who are below 18 because you don't want the parental consent issue. Sometimes it can be maybe you are doing a study on victims of crimes and you might want to exclude certain maybe people who've been exposed to certain kinds of crimes to avoid re-traumatization. So there are always there's the ideal that you start with, and and in terms of how good you are able to exclude and work within your constraints, it's based on how much you know about the data that you intend to collect. Sometimes it can be that you have to, what is dictating how you must do things is the specific research focus, right? If you are doing a study on access to healthcare, you might have to now define your population based on those who visited the facilities within a certain time frame. So there are those considerations that you need to take into account. I'm just going to look at the non-probability sampling, and then I think we will have time. I can show you the Excel, how the implementation in Excel of some of, especially the probability sampling approaches, so that they make more sense. So with non-probability sampling, we've already said that you don't need a frame with non-probability sampling, and mostly we use it because of in the context of the quantitative studies, it's appealing because of that. And then that says there is that easy access to your participants. So there is volunteer sampling. The participants, they volunteer to participate. If we think about customer satisfaction surveys, you volunteer to participate. They send you, it's up to you whether you fill in the form, or they send you a text. Maybe they say you must rate the service. It's up to you whether you rate the service or you don't rate the service. Convenience sampling, you use participants that are accessible. So if you go to the if we actually go back to our a student example, with volunteer sampling, you would send to everyone, right? You would send to everyone, and whoever volunteers to participate. So meaning that, remember with a probability sampling, you send it to those you select. So you get a frame, you follow an approach, whether it's simple, random, systematic, or stratified. You only send the questionnaire, if it's a questionnaire, to those that you have sampled. With a non-probability sampling approach, you would send to everyone. So if they give you a list of all the students, you would send to everyone. And it will be based on those who volunteer. So the challenge here is that you might find that people who volunteer to respond have certain attributes. So it is prone to bias. So if, for example, you are looking at something about satisfaction with customer care, or if it's students, you are looking at the University of South Africa and you are sending to all the students, they have to give feedback on the customer service, the service they are receiving from the university on different things. You might find that the students who are likely to respond maybe are the ones who are happy, or the ones who are likely to respond are the ones who are not so happy, so they want to voice out. So there is that bias that can be introduced, and you can't see it. You'll only see when you analyze that. Maybe sometimes maybe it's not a bias. Maybe the students are happy, right? That's what you are seeing in the results. But sometimes you are seeing the students are happy because those who responded are the ones who are happy with the service, or are the ones who are not so happy with the service. Yeah. And then if I go to convenient, if I use the example of the students, maybe I'm gonna go on campus and distribute the questionnaires, or with a tablet, approach students. That is convenient. Approach students, and those who agree, and then I'm able to take them through the questionnaire, even if it's not paper on a tablet, but it's more the ones that I can access at these different institutions. So that would be, if let's say I'm not using, maybe I feel that I'm not gonna get a good response with the form, so I'm gonna go physically to the different institutions, and I will be approaching the students. And if you meet my inclusion criteria, so obviously I'll have to first ask you if you are full-time, part-time, your age, the criteria that we spoke about. And then once you meet their criteria, then I can take you through. That will be convenient, the ones that I'm able to get. And also the example that I've given here about if you are doing a UNISA with the satisfaction, you go to the library and you wait for students who are coming in or coming out. That is going to be a convenient sampling. And I can also get a list from the university and send them the form. Then they will volunteer to participate. So your method is usually influenced by something. Most of the time, the people who go physically, it's because they know that with the form, they might not get a good response. But if they go there, they're able to build rapport and encourage the people to participate in the study. So a better response rate. Purposive is when the researcher chooses who must be sampled, right? Based on the research questions. So maybe you you target a certain population that has certain qualities. So maybe if you want to investigate a certain religious belief system, so you'll target that group and you'll probably go where you know you can access this group of people. So that's going to be purposive sampling. Snowball sampling, it's when you recruit some people, and the people you've recruited, they refer you to other people who meet your inclusion criteria. So example is maybe it's if you're studying something maybe related to a rare disease. So you find that people, you know, there are groups, support groups, you know, with certain diseases. So you might find that you find a few participants, and they're able to refer you to other people they know based on these support groups that they are part of. So that would be a snowball sampling. So if you know it's difficult to access your participants, then you can use a snowball sampling using the referral. Sometimes maybe it's you are doing businesses who are doing participating in a certain business activities, and maybe you don't have a list and association, but sometimes the people in the industry, they know each other, so they can refer you to the people they know. Then that's how you will get your sample. Then there is quota sampling. Quota sampling is similar to and to stratified, right? So with the quota, it's you don't have a sampling frame, but you know the population size. So you are able to say that if we use the example, yes, let's use the example of the students. The university can tell me that they can't give me a list, maybe for whatever reason, or I don't want to go the list route because I don't want to be frustrated with having to follow up. Remember, with probability sampling, if you sample me, you can't replace me. You have to collect data from me. So you have to follow up with me until I respond. So maybe I don't want to go the probability sampling approach. I want to go non-probability, but I know that the three universities, they differ. So because they differ, I'm not going to lump them together and do a simple random sampling, but I'm going to stratify. So I stratify based on the variable. In this case, the variable we are using is access to healthcare facilities. And then I will be able to ensure that I maintain certain quotas. So same, most of the time, as I say, we use probability proportional to size, meaning the big university will get the biggest share. So if, let's say, I send the questionnaires to the students, so what I will be, I'll make sure that once I get 40% from TUT, I no longer collect from TUT because I've reached the quota. I wanted the students from TUT to make up 40% of the sample. So once I get 40%, I no longer take. Then I just push the other universities for me to get their quotas. If, let's say, what is left is 60, maybe I had given them 30-30 or 30-20, 40-20, whatever the allocation. You collect based on the quota that you want to reach. So you don't just say, as long as I have 300 students. No, you say, I need 300 students, but TUT is the biggest, so it must get the biggest share. So I'm going to send the questionnaires online, but from TUT, I'm only taking 60%. I'm taking this number. From UP, this number. From Sefako Makato, I'm only taking this number. In that case, I want to make sure that they are well represented, the different institutions. Yes, the only thing here is that you are not doing a probability sampling. The how part is it's convenient or it's purposive. Convenient, it will mean I'll go to the universities, but from TUT I'll collect up until I get the number and to maintain the quotas. Yeah, so I think I've explained what is in the slide. And the quotas also, even when you are not doing convenient sampling, sometimes you want to still make comparisons, right? So that's why maybe you want to have certain numbers. Or sometimes you don't want to make comparisons, but you want your sample to be representative. So you will ensure that you have a voice from TUT, a voice from the other two institutions. So you are doing it to ensure that you can say your sample is representative, because if you do convenient without the quotas, you might end up with 80% of the sample coming from one institution. And if you think that they are not homogeneous, then it means your sample is not representative. Yeah. So I'm going to pause here, and I can take questions and look at the questions. And there is also this the quiz that I would like us to go through as I look at the questions, and I will conclude with showing you how to do the some of the things in Excel, the implementation in Excel, because we've just looked at how to do each approach, but maybe showing you in Excel will assist to actually shed light on how, especially the probability sampling, how they differ. And how, for some people are thinking, how do you actually do it? So that will assist you to see how you can actually do that. So I'm just gonna move to the Q&A. Okay, so the first question, thank you for the questions. I want to interview young Black academics at UNISA. What process can I follow to ensure that it occurs successfully? So you will have to, you obviously, I mean, before you, I assume your study is conceptualized that way, but for you to maybe refine it properly, you might have to first talk to someone who is inside, maybe to give you more information about the context. Yeah, the context. But then in terms of the process, then obviously when you have done your proposal, you would have to get ethical clearance. And from the ethical clearance, when you apply, you will specify that you want to interview young Black academics at UNISA. You will motivate why that particular group. And based on your motivation, your submission, the university will then, obviously, when you have applied, you get a response to say you are given the ethical clearance for you to proceed, or there will be questions, or there will be recommendations. So the first step will be to apply. But my advice is first, if you are outside the university, have engagement with someone within the university who can assist you to understand the context better, so that even as when you finalize your approach, it's informed by you are not just doing it without any knowledge of the environment. It's always important to have information about your population. Then you sometimes you know at that point what is not going to be possible and what's going to be possible. So in your proposing, you lean more to things that are feasible. Otherwise, when you are very remote from the context, you might propose things that will not work, and that's going to delay you. Yeah. Is the total population a type of purposive sampling? Okay, so if you are doing the total population, we say it's a census. If you selecting from so there you won't be sampling, right? You are saying the population consists of 150 learners, and I'm gonna collect data from 150. So I'm not sampling. I'm saying the population is a small population, but convenient sampling or purposive or non-probability sampling, you have a sample size. This obviously this workshop doesn't cover the how do you determine the sample size, but you have a sample size, and then yes, you have the sample size, and then you have to you have a sample size, and then you have to you send with the non-probability sampling. The issue is, even though you have a sample size, if they give you a list, you still send to everyone, but you collect up until you get the number that you are targeting. If you have quotas, you collect until you reach the different quotas, as I've explained. Yeah, okay. The next question, I'm not able to respond. You can mix a probability sampling and non-probability sampling if you the collecting data from different groups, right? You might have to use different sampling approaches. So it is possible for you to use a probability sampling approach for one group and a non-probability sampling approach for another group. Maybe for the one group, you have a sampling frame and you actually want to follow a probability sampling scheme. For the other group, maybe you don't have a sampling frame. Or maybe for the other group, you are doing a quali, the other group, you're going to be collecting data from it using a qualitative approach, and then you're going to have a non-probability sampling approach. Even if you are collecting a quantity from two groups, sometimes the dynamics for the groups, let's say you are collecting data about students, and maybe the other data you are collecting maybe about lecturers. So you might decide, for this group, I'm gonna follow this approach. For this group, I follow this approach. And obviously you will have a motivation why you are not following the same approach. It could be, with the students that they are likely to respond. So you following a probability sampling approach is not going to result in a low response rate. Maybe you know that the staff members, maybe the response rates, they tend to be low. So you rather go convenient so that you are not stuck with what is sampled, but you can take the people who are volunteering and you can encourage people to participate. How can we take volunteer to participate? Because alone can. I'm not sure if I understand the last question. How can we take a volunteer to participate for non-probability? Yeah, non-proper or volunteer cannot certify. I mean, the thing is, the sampling you have to take into account the practical uh, realities, as I think I mentioned some of them. In other cases, you don't have a sampling frame, so you have to work with what is available, meaning that you have to um, take the people who you have to go non-probability sampling, whether you go convenient or you go volunteer or you go snowballing. If you don't have a sampling frame, you can't even explore a probability sampling approach unless maybe even if you don't have a frame, you have some information about the population, which maybe you can have some form of a list, as I used the example of households, that when you know that in this area you've got 300 households, even though you don't have the list, but you know that how the area is structured, it's gonna start from a certain number, it will increase, so you can be able to do a systematic sampling approach. Maybe I missed some at the beginning. For conceptual framework, creating a visual, what steps for the method for data? There is no people involved. So I'm not sure if there are no people involved, if you'll be collecting data maybe from documents. Yeah, because you have to collect data from somewhere. Maybe I don't understand the question. If maybe one of the colleagues, if they understand it better, maybe they can explain it. Why we put part-time in exclusion, since it's known from the inclusion that it says full-time, same age. Yeah, it's just for you to be very explicit to say who is excluded. Yeah, it's just for you to be very explicit. I think what you are saying is that maybe it's implied, but you just want to make sure that it's clear to the next person who's included, who's excluded. How do I sample UNISA students in the regions? Yeah, so if you're gonna use UNISA students, as I say, do some background, get some background information about how the university is structured, the different regions, and how different they are in terms of what you are studying. Are they different in terms of what you are studying, or are they all the same, right? That will assist you to decide whether you need the different regions or if one region is enough. But if you really, your question requires you to do the regions, then you'll explain in your proposal that your study is about UNISA students, and because of they are not homogeneous with regards to these attributes, you're going to be stratifying by the regions, because these are the differences that are there, such that you need to look at the different regions. They're not the same. And then you apply to the university to give you access, because they need to give you permission to access the students. So maybe they will give you they will give you access for you to be able to send your questionnaires to the students. If you are doing the regions, UNISA has so many regions. So you have to think about them and see, are they all different? Can you group others and make some others maybe are more similar than others? So maybe others you can group them to make them to become one group, or do you want all the regions to each one must be a group on its own? So that will depend on the differences that are there. As I say, depending on what you are studying, it's possible that some of the regions are, maybe they are similar with regards to what you are studying, such that you can group them. And maybe you don't want to compare them, but you want to select per region to make sure the sample is representative. That's also okay. If you want to select from the regions because you want to compare, then you just have to make sure that you have enough respondents, enough students per region for you to be able to do the comparative analysis. Maybe you'll have to talk to a statistician to assist you to see if the allocation for each region, if you have enough sample to make the comparison. But yeah, you have to get permission from the university, and it's the university who's going to give you access to contact the students so that you can collect data from them. Okay, this was the same. How do I have to? Okay, if I have to explain my sampling technique in my research report, how do I go about? What must I include? I mean, here the sampling is it's where we are explaining the sampling. It's the method, right? Before we get to the method, you should have explained the research design, whether the type of design, and maybe you're gonna be doing a cross-sectional study, or whether you're doing a retrospective. So before we get to the sampling, there are a lot of things that you should have explained. At the sample selection point, you'll give us a picture of the population that you want to study, and then you describe it. And as you describe it, you also give an idea of its size, right? And then from there, you'll be able to tell us whether you're doing a probability sampling approach, non-probability sampling approach. If you're doing probability sampling approach, then you go further to say you're going to use stratified or systematic or simple random sampling. And obviously, as the one part that you will also have to specify is how many. You've given us an indication of the size of the population. You must now say, based on this population size, these are the number of units that will be selected, and this is how I'm going to get them, which is what we look at today. I will do a simple random sampling or convenient, or I'm going to do snowballing, which is, so you have to explain like that. A population, then you tell us whether you're going probability, non-probability, and you also tell us after the population, you tell us how many units you're going to be selecting and how you're going to be selecting them. Yeah. Can you use stratified random sampling in homogeneous? You don't need to stratify if the population is homogeneous, right? Because they are the same. So if they are the same, why do you group them? What are you going to use to group them? Because we group them by the variables that make them to be different. So if they are the same, they are homogeneous, then what are you going to use to stratify? So when the population is homogeneous in relation to your variables of interest, you don't need to stratify, because whether you select me or you select you, we are homogeneous. So I just need to get the right number. It doesn't matter. But if we are different, then you need to create the different groups, right? And then make sure that they are well represented. I'm investigating a relationship between two constructs. I've got biographical variables such as age, group. Which variables can I use to stratify? Okay, I think here you have to look at the literature in terms of, are there from these variables, from the literature, what does it say in terms of, are there differences, right? And so it will depend on two things. It depends on your objectives. If, for instance, you are collecting the variables, sometimes the variables, the biographical variables, we collect them just to describe the participants that we collected data from. So we're not collecting them because we want to use them for comparison. Sometimes you collect the variables because you want to use them to describe. When someone looks at the participants, they have an idea that, okay, it was this was the average age, so they have an idea of the population. So you are not intending to use these variables further. If, however, you want to use the variables further, maybe for comparisons, as you are informed by the literature, then it means that, because if you're gonna compare by educational levels, then we need to have people in the levels. So because you can't do a comparison if you don't have observations in the groups that you want to compare. So you will stratify so that you have enough people within them, the different groups, so that you can compare. I mean, with the case that you've put here, it's not going to be possible to stratify by all of them, because you don't have an unlimited like population. It's not going to be possible. You'll have to select what is key, the things that you really want to compare by, and those are the ones that you can use to stratify by. But with this list like this, you can, if your population is very big and you know that you will get you'll be able to get the breakdown. But yeah, I think there are so many, so you might have to select the ones that maybe weigh more and use them to stratify based on maybe the comparisons that you want to make in the analysis. Okay, this one, I want to study grade 10 students of 10 sessions with different student number. They are homogeneous. I want to allocate sample size for each class based. How can I allocate the sample of 10 sessions with student? Okay, they are homogeneous. Okay, I'm not sure, because you are saying they are homogeneous. So I'm not sure where the stratification comes in. But if, let's say, you have 10, you have to first say what is the population size, right? If the population size is 300, then you will have to estimate the sample size. If, let's say, I'm just giving an example, if the sample size is 150, I'm just giving an example, then, and you have these 10 groups, then if you want to use the proportional to size, you'll have to say they are 10, right? So you need to say maybe one group, you need to look at the share to say if they are 10, maybe in terms of the population, we use the population, right, to do the allocation. So if from the population, let's say the first group, you have, but yours are what, they're different number, yeah. If from the first group you have 20 students, it's got the biggest share, you use a percentage. I think I must maybe say it that way. You use the percentage. You're going to say, I have total is 300. I have 20 from group 1. So you're going to say 20 divided by 300. That will give you a proportion. You multiply by 100. It will give you a percentage. Then you will be able to say That is the share for that group. The next group, how many learners are there? If it's 50, you'll say 50 divided by 300. Multiplied by 100, it's going to give you a share. So you know when you have a sample, whether the sample is 50, 100, second group, it's going to get its share based on that percentage. The first group will also get a share based on that. So it gets a share based on its size. If it's 20 over 100, 20 over 300, multiplied by 100, it's going to get that percentage from the sample size. I hope I make sense. I think I've looked at most of the questions. I'm not sure if you were able to do the quiz. Okay, there are some responses. Thank you very much. Let's maybe look at the quiz. So the first question says, I have 50 students from a class of 150. I want to select 50 students from a class of 150. If you put the names of all the students in a box, so 150 students you put in a box and you want to select 50. If I select 50 without looking, what will be the sampling strategy? So remember, they are all in the box, 150, which means they are in one box. They have the same chance of being selected. So this means that it's going to be simple random sampling because you didn't stratify, you didn't separate them by anything. You took 150, you put them in the box and you select 50. So they each have the same chance. The chance of taking student number 50, number 1, number 3 is the same as selecting student number 6, number 7. So it's going to be none of the above. It is simple random sampling. Same question, you want to select 50 from 150. If I stand at the door in the morning and I select every third student coming in, what is the strategy? So here there is stratified cluster. So it's going to be systematic sampling because we said systematic random sampling, there has to be a random start. So here it was not a random start. It's me as a researcher. I just decided I'm going to take every third student. So it's not a systematic random sampling, it's a systematic sampling. 50 learners again from 150, and they are coming from 3 classes, this 150 now. Now I have 3 classes. If I randomly select one of the 3 classes and use it as a sample, then that's going to be cluster sampling. Yes. And if I obtain a record of learners, so I have a list of learners, some of the learners have allergies, others don't have allergies. Suppose we randomly select within each of the 2 groups, right? So some have allergies, some don't have allergies. And the number of learners in each group is representative of the, so this is gonna be stratified because I'm selecting in this group, I'm also selecting in the group without allergies and the group with allergies. So it's stratified. Then there's this one, it's the same example, but now you're just ensuring that 50% have allergies. So it's actually an equal allocation here. I take 50% from the group that has allergies, and I also take 50% from the group that doesn't have allergies. So here it's still stratified, but it's equal, 50-50. So that's gonna be a stratified. It's not because I have a list, right? So I have a sampling frame because I have a list. I said it's a record. Once I have a list, I have a frame. So I can do probability sampling. So here I have a list here. So that's why it's not quota, because I have a list. It was going to be quota if I didn't have a list, and maybe I was, they were volunteering, or I was looking for convenient. Here I am selecting them from the list. The only thing is I'm making sure that from students with allergies, I take 50%, and I also take 50% of my sample from those without allergies. This one is about baby milk preferences of mothers with children under 1 year. If I target mothers with babies who are coming to the local clinic, if I ensure that the number of sampled mothers who fall into different age groups and social classes is strictly controlled. So here I don't have a list here. I'm approaching mothers. Yeah, I'm assuming I have information on the age groups and the social classes somehow. So it's going to be, maybe here the confusion can be, how do you get the information about the age group and the social classes? But it was conceived to be a quota sampling, because here there's no list per se. You are approaching those mothers. But I suppose the challenge now is, how do you know which ones belong into which class? If I was giving them a form to complete, I would be able to establish this. So you can select your age and the social class, whichever way I'm going to define it. Then I'm going to make sure that I maintain the quotas based on the age groups and the social classes. Then this one is about milk preferences again. But here, the mothers, they are recruited through social media. So here, it's gonna be convenient, right? It's whoever I can find. And I'm sending the questionnaire, and I'm using social media to approach this mothers. So it's gonna be convenient. And this one, if you are doing customer satisfaction among honors, if you select students from one college to represent the university, then that's going to be a cluster. But we are assuming that that college is representative, right? So once you select a cluster, the assumption is, so it's going to be the same with the question of the region. If you select one region, you are assuming that there is this region is representative of the other regions. That has to be a fair, obviously, for you to make that assumption, it has to be fair. If you are doing customer satisfaction, again, honors, postgraduate diploma students, you send your survey to all students. You collect until you reach the required sample. Then what's going to be this strategy? Then it's none of the above, because it is quota. It's none of the above because it's going to be quota. It's not quota until you reach the required sample size. Yeah, it's convenient because there are no quotas. You need 300 students. You send to all the students. They give you a list to send to all the students. When you get 300, you stop. So it's going to be maybe convenient, or maybe we should have used volunteer. But yeah, it's not going to be a probability sampling approach. This probability sampling approaches are not applicable because you don't have a list. You don't have a list, but you are sending to, you don't sample, you don't do a probability sampling. They give you all the students, you send to all of them. When you get the target number, you stop. So it's convenient. This one, we've used this one where they send you something to rate the experience, right? So here I said select all applicable. This one you can select because it can be that maybe it's a simple random sampling. So from their customers, they have a system to select randomly, and they send the question or the rating question to those they select randomly. It could be that they use a systematic random sampling. So they say, we start at number 20 for the day, we start at number whatever, and every fourth customer, we're gonna send the question to rate their experience, right? It can be stratified if maybe they have different customers and they've grouped us into different groups, and they want to make sure that per day they meet, they get 2 from this group, from that group. So maybe they've classified us as customers. Convenient if they are sending to everyone, it can be volunteer. So I think we are at the end. So with this one, it can be a lot. It just depends on the approach that they are following. Yeah, I'm gonna wrap it up here. Unfortunately, due to the time, I'm not able to show you the how. But if there is interest, I think you can indicate to the coordinators if you want to see a demo. This is applicable to probability sampling. To say, okay, I want to do simple random sampling. How do I do it? The demo that I was going to show is in Excel, because most people have Excel. You don't need to have a software. But obviously with the softwares, your SPSS, it can actually do the simple random sample for you. The different sampling approaches, they can be done. But yeah, the easiest is to use Excel when obviously you don't have a big population. Obviously, when you start to have big numbers, it's going to be very difficult for you to follow what you are doing in Excel. But to visually see it, it's good to see it in Excel, so that when it's also done in SPSS, in your mind, you know what is happening in the background. That's how the Excel will help you, that even when you are doing it in SPSS, in your mind, you know what SPSS is doing because you have seen it in Excel, that this is actually what is happening. So that will depend on if there is interest in that. I'll hand over to you, Bronwyn. I think I'm going to pause here.